Good afternoon, everybody. I am Dirk of Eurocircuits, managing partner and the guy at the very cradle of Eurocircuits, together with my university colleague Lux Metz. And I'm very happy to meet the design community in the UK on EDS Reconnect. My presentation today is right in the middle of what we do as a service provider for making prototypes and small series. It's bridging the gap between your CAD site and our CAM site. And let's take a closer look to what that means. It means also achieving right first time for manufacturing, and I will come back to that later on. Well, in the design process or in the entire value chain, if you think about designing, then first you think about functionality, the ergonomics, the aesthetics, the manufacturability. But to be able to think about this thoroughly, you need information. And this information usually comes from the manufacturing side, namely, what are the capabilities, the design values, the manufacturing constraints, and so on. And the first thing in this process is defining your BOM. But there is a bit of a little difference in the way we and you look at the bill of material. As a designer, you look more in terms of electronic functionality, and you use tools like the web and so on. On the manufacturing side, we look at what is the availability of this, what is the effect of these components on manufacturability, the feasibility, the reliability, and are these proven and tested components in our database? So already there, our vision on things is a little bit different. So defining your BOM can be an important part in your design process, where you talk with manufacturers to get extra information. Now, we are dealing with 12,000 customers with over 20,000 users of our system. So what we have built is a BOM generator on our website. You can throw your BOM in and you can start analyzing it and verifying it with our verified component database. The next thing you do is size the PCB and place the key components. I'm going over this in a little pace, a little bit faster than usual, because I have only 40 minutes and I don't want to be cut off at the end. So, but you will all be able to look at the presentation later on. And also here, there is a difference between the designer and the manufacturer for sizing, because you need to size the PCB according to the application you're building. But the manufacturer looks how efficient is the PCB on a production panel. And for a big series, this might be an important parameter. So definitely also something to take care in your consideration. Defining a PCB is not so very easy, because you need to think about what are the cost drivers, what makes a PCB hard or impossible to produce, and which tools are available to help me with this. The best you can do is talk a one-on-one with somebody who knows everything about manufacturing. But as I said, that's very difficult today. So you will be looking for capability catalogs. But do we really still read those things? We have the experience, people don't. So what we did is we created online smart menus that help you through this. And what does it do? You can immediately start calculating, and calculating doesn't really mean only getting a price, which is important. If you are at the beginning of your design process, you want to know roughly what you are talking about, but much more important for us than that on the technical side is that all the technical restraints and the rules of combining what with what, they sit in the calculator. To give you a nice example is build-up. Build-up or stack-up is one of the most critical things to choose from. If you start building your own stack-up to your own liking, to what you can find on the internet for materials, then you're not sure if they are available, if your manufacturer likes to work with them, how long will it take for your manufacturer to get them in stock, and so on. So all of these rules about build-ups, stack-ups that we have in-house and the materials that we have on stock, it's in the build-up editor. And the build-up editor does a lot more. It does also build-up validation. It tells you, for instance, this is an example of a 6-layer with blind and buried vias, whether this will work or not. If you choose a via combination that we cannot produce, then the system will tell you. It will also tell you if you have chosen a very expensive combination with the coins next to it. Here is an example of a buried via which we, for instance, would not be able to produce. And then the system tells you in the remarks, this is not possible. Another thing that we brought in is in the build-up validation is special build-ups for making defined impedance cards. Yeah, also there you can design whatever you like with info you find on the internet, but that doesn't mean that your manufacturer can produce it. We started from the standards here and propose the build-up to start with. Because once you find your liking in these proposed build-ups, then that is already a hurdle taken, which you don't have to think about anymore. Starting with the calculation from the beginning and typing in the technical parameters you are thinking about is very important. This is an example where you choose base copper of 70 microns in your that you would need for your design. But you say, okay, I want a track width and a spacing of 0.1 and a spacing of 125 millimeters. Then the system tells you automatically that is not possible because we need a minimum of 0.2 millimeter. And then it's very obvious this is information you would want to know before you start making your layout and not afterwards. Another thing that speaks for itself is what are poolable options. We are a specialist in pooling, order pooling, which means bringing orders of different customers together on one production panel to save cost. Now, if an option is poolable, we will tell you this. If an option is non-poolable, meaning we will need to make a full production panel for you, then we will tell you that. Same thing with classification. I gave you the example before of the thicker copper, which will bring you in another classification of parameters for track width, spacing, annular rings, and so on. And it are in the end exactly these parameters which you need to fit in your CAD system for your design rules. Another thing we help you with is production panel efficiency. Here we have a panel for a series. If you make the number of boards you want large enough, then we are not talking about pooling anymore, and we give you an efficiency parameter of how many boards of this would fit on a production panel. And just by changing your customer panel for the same PCB, the price of the board would go down dramatically just because more customer panels would fit on a production panel. So I think that is a rather important consideration to make. Now, if I'm talking about customer data, which will be the next subject in what we deal with, is just to clarify who we are and what we do, and if I'm justified to tell at all something about customer data, is a question about how many data sets do you think that Eurocircuits processes on a daily basis? Would that be 200, 500, 1,000, 1,500? Usually this would come up in a poll. We don't have the poll now, but the answer is not so important. Posing the question and make you think about it is, and the answer in reality is we process around 1,000 unique PCB data sets on daily basis. Through our service, they come around 3,000 data sets. It means people are iterating. You load up your data, and then you say, okay, I found 1 or 2 mistakes in the data, or the system flags it up. You repair it and you upload it again. Then it's only one unique data set because we identified that as the same one, and that's what I mean with 1,000 unique data sets. So I think we have some experience in looking at customer data. Looking at customer data is the next step we do. And what do we do then? Then we transfer the data to the manufacturer. And that's the first thing. Bring the data from your side to our side, because how else can you work together? So how do you do that? There is no such thing as a general format in which all your CAD data can fit. So there are multiple formats invented to do this. And on the left-hand side, you see the native CAD formats we read, and that is Eagle and KiCad. There we read in directly the native format, but for all other CAD systems that's not possible. So you would need an intermediate format. The ones mostly used today for pure PCB data is the Gerber X2+, which contains everything you need to know about a PCB, but also ODB is nice, and Gerber X3 if your CAD system can do it, because those two formats also contain the assembly data. Data should primarily be very clear, and that already starts if you want the engineer to look at your data later on. Use clear layer names. Another tip is to not mess with polarity. Do not invert layers anymore. This is a trick from the old days when we needed to fit our Gerber data on a floppy and send the floppy to our manufacturer, but that is not needed anymore in these days, and still people do it. Another very hindering thing that makes manufacturing sometimes impossible is when you start mixing different units, millimeters, imperial, all in the same design, and then not choosing the correct grid to do everything with. Then for the manufacturer it becomes rather impossible to align everything perfectly together, so that you should avoid. We would say work in millimeters and put your resolution as high as possible and your grid as small as you can manage. Another thing is bad outlines. I mean, this is a typical outline from an old CAD package, Ultiboard. Still, some people are using it, and this package uses crosshairs as an outline. Now, there is no CAM system that can read such a file automatically, because it will say it has no valid contour. Also, avoid information outside the PCB data contour. There is no point in putting all these frames around your data or putting measures in how big your data is. The computer is much smarter than the operator behind it and can read this perfectly without all this cluttering information. What we propose is that you load your system and that we present you with a mirror of your data. So you load your system and you load your data, and this is how we see your data. That's the first step in the process. If we then find confusing layer names, then we have a way to do a dialogue with you, and you can immediately point out, okay, this layer was not some drill file, no, it was the top solder mask layer. And then the system processes the layers again, and everything will be clear. For the assembly data, this becomes much more complex, because nothing is standardized in the world of assembly, and then BOMs can look like this. I would call it gibberish, because everybody can define the BOM in whatever format they like. For that, we have made an import wizard, so that you can assign and you can say this column is that, this column is the reference designator, that column is the manufacturing part number, and so on, so that again this can be clear, because the first thing we want to establish is that the communication between designer and manufacturer is crystal clear. You can do that in form of a dialogue or with tools in the way we propose. The same thing is for the component placement list, which is the third set of data we would need to make a completely assembled board for you. Now, if you look at the communication of bringing the CAD data to the CAM side, then you might think of what is the biggest problem that we are faced with in just this communication. Would that be the PCB outline incomplete or missing, the drill map instead of the drill file, missing data, or just merge layers into one file. Believe me, that happens, is that the solder mask is combined with the copper in one layer, or incorrect data formats like a PDF. We get the drill data in PDF, so what to do with it, or multiple designs in one supplied zip file. Which one should we make? One, two, all of them, none? It's very difficult. So, but the question is simple, or the answer is rather simple, and that is, from all these things that happen frequently, the most frequent mistake is that the PCB data is supplied without a good outline, so that the outline is not completely closed or is missing altogether. And in that respect, you can't start a DRC, you can't do design rule check, because any system will say, hey, what is the boundary of my PCB? The next step, when the data is clear and everything is read in, is that we start analyzing your data. If everything is okay, that's fine. Then we go to the next step. But let's talk about when it's not okay. What can happen? We do DRC, DFM issues, and we flag them up in our PCB checker. And we show you every and individual issue that you can go through. And what can be issues? PCB production issues can be like this. The small, where the red arrow is pointing at, is these little openings in the copper. They are not so annoying for you, but they are very annoying for us, and they, let's say, they scramble up our production process, because in the developer, these parts of the dry film, they get loose, and they may land somewhere else where they create problems. Holes of different nets that are too close to each other. This is a typical thing with a small connector or pin header, and that creates problems, because you need more meat between the hole walls. And on the right hand side, you can see what is accepted or not accepted in terms of pads and holes that are very close, and how to use an oblong pad to prevent breakouts. Another thing is annular rings is a very common mistake, that the annular ring is not well respected, because we think in tool size how to drill a hole, and a designer thinks in what is the final hole size, and that may create misunderstandings. So we have created also a special tool for it, and that is auto repair, which we will always apply if we can do it, especially on fire holes. We have a drill editor, and why is that? In the old days it was very simple. A hole with copper on both sides was plated through, and a hole with copper only on one side or no side was non-plated through. But these days you see all kinds of different combinations, and then we offer the customer a tool to say what specific hole it is. There can be solder mask issues, where, for instance, a solder mask pad here for the ground plane for the component is forgotten. And solder paste editor is also something. If people make their own solder paste files, we have created an editor that facilitates to do all kinds of fancy stuff with your solder paste to order the right screen for solder pasting. Expensive CAD systems, they can include all kinds of text and logos and whatever on the PCB, but many CAD systems cannot. And we have found an easy trick and an editor for it, a marking editor, where you can import a JPEG file or a PNG and just can put it on your board. Here you see it in the upper left corner with a red rectangle is a logo put on the board. So this facility is there. Another thing which is important that you let the manufacturer do is making customer panels, because we respect the rules of where to put bridges, make sure the panel is stable, that the right routing is used, and so on and so on. So for that, if we also created a software to to provide you with to make customer panels. A BOM editor, since it is these days a hard task to find components, we need handy tools, first of all, to understand what you want. Here you can make it clear. If you don't do it yourself, our operators will use the same tool to look for the correct components. And if they cannot be found, the tool can also be used to find alternatives. So it is definitely something, definitely also in the beginning of the design process, to use this tool and to look in the database eventually for alternative components. The Cpl editor. In the Cpl editor, we read in the placement data, and Cpl stands for component placement list. We place the components that we found in your BOM list on the set of Gerber data. We are not yet in the stage of the order. We are still in the stage of dealing with your data in the communication before we make something for you. And this is interesting because here we can, of course, check if everything fits together and if the footprint of the component also aligns with the Gerber data underneath, which in many cases it doesn't, like in this case. And then there can be two things: either the footprint of this component is wrong in our database, or the footprint of the component is wrong in your database, or the component notification in the MPN number is slightly wrong and it is a different component that we are talking about. So this needs to be sorted out before we go into production, because if the layout needs to change, then you need to iterate the layout process and upload new files, or we need to order a different component so that it fits. Design for manufacturing is a very important thing for looking at PCB and assembly together to avoid mistakes. I think every EMS, electronic manufacturing service provider in the whole world can tell you that every day they meet the problem that they order the PCB from a PCB manufacturer, they order the components from the component manufacturer based on your data, and then everything arrives in logistic. They do a quality check, and before they go into production, they are faced with the fact that the PCB and the component is not matching. So that is a very, very, very important issue to deal with before you start ordering something. And then that is definitely something that we show in the assembly checker and the assembly editor, where you can see the build board with the components on top of the PCB without that we have produced anything. This is all virtual. As virtual as I'm now talking to you, we do this in the free-to-use tools we have available. And there are probably other parties in the market that do it as well, but we do it online, and I have not seen anybody else doing it online. Offline, there are various possibilities you can go in the market, but it is important to do this check. Aligning the components on the PCB is important for checking, but it's later on also important for us. If we do the assembly, then our operators are doing this in the work preparation for the assembly. But if you want to make absolutely sure that your component fits, it's definitely something that you can check before order as well. And also check if the rotation of the component is clear for everybody, especially with symmetrical components. Is it clear which is pin 1? Is it clear which is pin 1 on the component, and are they at the same rotation? This is a typical other example where a BGA is 90 degrees rotated to the right. So to correct it, we should, the image on the left, we should rotate counterclockwise 90 degrees, and then it's, or clockwise 90 degrees, and then it's okay again. On the right hand side, same problem, but there it doesn't quite fit. Why is it so complicated, this assembly information, and why isn't it straightforward? Because in your CAD package, it's clear. But the problem is, once you start outputting your information and the manufacturing party receives it, all of a sudden it's not so clear anymore, because there are no conventions, or there are conventions, but not one single convention. In this case, there are already three: the IPC, the EAC, and the EIA, and we follow the IPC. And all of them have a different idea about where pin 1 should be and how to indicate the rotation of a component. And then there is even a fourth standard, and that is the standard that you make yourself, because every designer can make his own standard. Why? You're not obliged to follow any of the other three. So basically the number of standards is indefinite, and you will always understand your own design in front of you in your own CAD package, but that doesn't mean that a manufacturer will understand it. And that's why the dialogue concerning data is important. Bridging the gap from CAD to CAM. We should fully understand what you meant. And the only way we can do that is hold a mirror for you, is say, when we receive the data, that is how we see it, and that is how we are going to produce it. And that is exactly what we do. In the next step, this is another typical thing that happens a lot, is that we check for is this one is a solder drain. So where you see the arrow, you have a via which is too close connected to a soldering pad. And what will happen is that the solder paste that you print for this pad during soldering will disappear in the via hole and will create a bad soldering connection. So in terms of DFM and DRC, which are the most frequent DFM issues? Like the questions before, asking the questions is a lot more important than giving the answer, because whoever of these 7 points win, all the 7 points, they happen a lot, and they are equally annoying and dangerous. So copper too close to the board edge is definitely appearing a lot. Annular ring minimum design values not respected is definitely happening a lot. Isolation distances in the same net not respected, as I showed you before, between the holes that were too close to each other. Footprint not correct. Daily stuff multiple times a day. Rotation or pin 1 not specified. Daily stuff multiple times a day. Plating index violations, so that the copper density on the board is very, very different on the same surface, and even between top and bottom. This will create a lot of strain on the board, bad plating in the holes, and possible bow and twist of the boards. And as a result, we create bananas instead of PCBs. So it's a difficult thing to deal with. And then BOM-defined parts not sourceable. I think we all know that that is daily practice today. And the winner is, and that's still for the last 30 years, as long as I can remember. I'm 31 years in this market now, and that is that design rule values for annular rings are not respected. It's one of the easiest things to deal with, and yet it seems very, very complex to get that straightened out and clear into the market. And that brings us down to the entire value chain flow, where we start with informing ourselves. We transfer the data from the CAD side to the CAM side. We analyze, we give feedback, and you have the possibility to update the design, and you can iterate this as many times as you want. Once the analysis is okay, you can place the order from the shopping basket to the order process. If it goes into order, then we make production data out of it. In the production data status, we give our customers again the possibility to say, would you like to see the production data before we go into actual production? You can tick that box. and then you get an email and say, we are waiting with our production for you to review the production data and to start the actual production. Then we go into manufacture, we make the boards, and we make sure that with our joint efforts of checking everything, of doing this together, of respecting the communication with each other, we make sure that your board arrives right first time, on time, accurate to your intentions, and at the best possible cost. And that is important because in the entire design value chain, one of the things that carries the most value and therefore the biggest cost is the time of the designer. And we should optimize this time as much as possible. And that is exactly what we strive to do at Eurocircuits with these tools that we put at your disposal. And that is say, okay, guys, use it because this will lead to right first time, on time, and within the cost that you were thinking about. I thank you a lot for listening to me. And if there is any question, you can put them in the chat and I will be most happy to try to answer them as best to my ability. This gives a small overview of who Eurocircuits are. We are specialized in prototypes and small series. We produce everything in-house in our own factories in Europe, according to European standards. And therefore, we are also very conscious about environmental issues, social issues. We pay our taxes and we do try to do everything right. And we are very, very sensitive to governance as well. So we have ESG as one of the projects we work on a daily basis. We have about 12,000 customers, 20,000 users. And every year we deal with more than 100,000 orders, of which 83% of the PCB orders are delivered within 5 working days. We started in 91. I still was a very young guy at that time. Well, I still feel young. I'm not so young anymore. It was 31 years ago. And we are now a team of more than 500 people in various factories or 2 factories in Europe, Hungary and Germany, and our engineering is in India. We have local sales offices, amongst others, in the UK, and in France, Germany, Switzerland, so all over Europe. And the group staff here says 475, but we are over 500 already this year. Still waiting for questions. There are at the moment no questions coming in. Over here I give you an overview of where you can find Eurocircuits all over Europe. And in the market of printed circuit boards, we are active in this market segment. I'm just giving you this as extra information. If there were no questions, and I could enlighten you in a bit of market background. The market in PCB manufacturing is divided in technology and volume. And for every quadrant, you have different manufacturing sites. So no PCB manufacturer does all these quadrants in the same factory. That does not exist, not in the whole world. So everybody specializes in one of these segments. And we are clearly specialized in standard technology, quick turnaround. That is our cup of tea. Our vision on the market is that we deal with components. We have a verified component database in which at the moment there are already 340,000 components in it. And of course we have those free to use tools. And here somebody asks, what are the benefits of using Eurocircuits rather than a competitor? Well, first of all, we offer you this pre-order, free-to-use interface, which I showed you before, to deal with the communication between customer and manufacturer concerning your data, making sure that you as an engineer, because our primarily customers are design engineers, but the engineer should stay in the driver's seat. We do everything very transparent. These free-to-use tools are there for you to use to make sure that the design before it goes into production is perfect and that you know every little detail about your data, which is not perfect, because then you can correct it in your database, in your CAD system. And later on, if you go to the manufacturer for making a series, all these little details are already dealt with, and you are sure that this will not repeat again. Also from us, you get the production data. Once your PCB prototype is made, you can download your production data. So we do everything in complete transparency because we believe that the design engineer should stay in the driver's seat of the whole value chain, following on what we do together. And I haven't seen this concept anywhere else. Also not from the company that I was asked here to compare with. Of course, there are a lot of, especially then Asian competitors that give their boards away for free. If you believe that there is no value in making a circuit board, then what can I say? I will never be able to convince you. Then please go ahead and buy from these people. But that is not a serious thought. A circuit board is not for free. A circuit board costs money. I mean, the production process is between 30 and 50 production steps. You need a huge capital to set up a factory. You need to comply with social rules, with environmental rules. You have many disciplines of different engineering people you need in your own factory. And those people are not for free neither. We don't use slave labor. I need to sign documents every day for customers that we don't use slave labor, and we don't. Well, if you're buying circuit boards for $2 or even less, and they give it for free and you only need to pay the transport, do you think that these people can do that without slave labor or without subsidies of controlled governments? So it's for you to decide. We are, in our heart, a European company. I'm not talking about EU, I'm talking about Europe. Britain, for all I care, is part of Europe. So we are a European company, and we deal with all these things that we hold dear. We support student teams, for instance. Students can learn electronics because we help them a little bit. Of course, the state pays most of the costs for educating our youngsters. But then again, how do we get this money together? With taxes. We pay taxes here. The manufacturers you refer to, they don't pay any taxes here. So I want to thank you for listening to me. And it was an honor of being able to talk to you about bridging the gap between CAD and CAM. I hope that you have learned something from it. But the basic idea is think before you act, and ask for information, ask for help, use the tools that are available. And hopefully in the end, if you decide who to work with, you choose an honest European neighboring company that does everything in its power to make our world here in Europe a better place and to help electronic designers do their job in the best possible way. That's all from my side. Thanks a lot for bearing with me, and hopefully meet you in person sometime.